Last thing that I want to do with you today is example number 2 on your example question handout. This is much like example number 1 was, where we had 3 charges in a row, where you had to draw that free body diagram, see which way the forces acted, add them up, and then solve for the net force. We want to find the net force, though, on sphere B due to A and C when they're at angles to each other. What do you think we're going to do? Yeah, but first, before we do a vector diagram, we've got to draw a free body diagram with the forces. Good. So let's look at object B here that is positively charged, and let's look at the 2 forces that are acting on B as a result of A and C. A and B, both positive, right? Man, are they going to attract or repel? Positive and positive going to? Right. They're going to repel. So that means that B is going to go left or right? This one's B? Yeah, it's going to be pushed away from A. So we're going to call that FAB, the force, the fab force, yeah. FAB to the right. And what about C on B? Positive and negative? They're going to, Justin? Go together. Yeah, they're going to attract each other because their opposite charges attract. They're going to go down this way. We'll call that FCB. If you're calling FAB the fab force, we'll call FCB the Fugub force.
Nice.
Now, this is not a vector diagram, but this is exactly what we did in the previous sets of questions, right? Draw the free body diagram, and then we calculate both forces. Hey, we can do that. FAB is KQA QB over R squared. That's 8.99 times 10 to the 9 times QA, which is 2 times 10 to the negative 6. We should have circled that because it's microcoulombs. Times 3 times 10 to the minus 6 divided by the distance, which is 2.0 meters, and then we square that. Let's calculate that fab force right now. What is it? Do you have it? 0.013485 newtons. And then we're going to calculate FCB, KQC QB over R squared. Same process, right? 8.99 times 10 to the 9 times, this time it's going to be 1 times 3 divided by 1.5 squared. That's going to give us a value of 0.011987 newtons. Now what? I think Brielle said it before. Yeah, vector diagram. So let's redraw that. We have a force to the right, that's AB. A force down, that's CB. .011987 newtons. And then this is going to be our resultant. How are we going to find R? C squared. Yeah, exactly. This is a question that a Physics 20 student that I teach right now, because we've just gone through vector addition in Physics 20, it's a question that they could solve if they knew how to find the electric force KQ1, Q2 over R squared. If I gave them this force and this force, they could easily solve this one, even though they've never done an electric force problem, right? It's just vector addition. It's math at this point. R is the square root of A squared plus B squared, and it works out to be 1.80 times 10 to the negative 2. And theta, which is the inverse tan function of opposite over adjacent, works out to be 41.6 degrees. Can anybody tell me why I'm not writing at 41.6 degrees south of east? I probably wouldn't have marked it wrong if you had of, but why am I not recording it that way? Yeah, like we're not given a frame of reference here, right? We're not told that this is north, south, east, west. So it's not really right to say north, south of east when like south and east aren't necessarily a frame of reference. Yep. Yeah, it does, because force is a vector, and unless it says find the magnitude of the force, then yeah, finding the angle would definitely matter. It's still a vector. But really, I'm describing the direction here, not in words, but I've labeled the angle as 41.6, so that's pretty much where we've got to leave it in this question. You get a question like this on a test, what it's probably going to do is have the angle labeled for you and ask you what it is, basically. Either that, or they just say, what's the magnitude of the force, and not ask you for the direction. All right? But if it just says force, force is a vector. You need magnitude and direction. All right, your homework tonight is question number 3 and 4 on worksheet number 7. The good news is, if you did questions 1 and 2, questions 3 and 4, there's going to be a lot of repeat calculations, which means that you're not going to have to do them again. Basically, you're going to have to set 3 and 4 up, draw your vector diagram, do the Pythagorean theorem, but the actual force values you should be able to steal from questions 1 and 2 if you know where to look. Okay?
So you can do 1 and 2, yeah.